Okay, today we're talking about factoring special cases. So before we go into factoring, I want to review how we got there, so how we multiplied them out. Okay, we talked about squaring a binomial, a plus b quantity squared, and we know that we squared the first term and we squared the last term, and then we multiplied these two terms together times 2. So our middle term was 2ab. And what changed if it was minus was just that second term was negative. So there it is algebraically. If we look at it here, we squared the first term, we squared the last term, and then we multiplied them together times 2. So that was plus 8x. Down here, we're going to square the first term, square the last term, multiply them times each other times 2, minus 6x. So that was squaring a binomial. And one of the things, well, we'll get there in a second. And the other one that we talked about was the product of a sum and a difference. Here we have a sum and a difference. And we looked at it the long way, but then we remembered that it was much easier and shorter that we knew we just squared the first term, squared the last term, and subtracted them. So x plus 2 times x minus 2 would give us x squared minus 2 quantity squared, 2 squared, excuse me, and that is x squared minus 4. So what are we doing now? We're going backwards, also known as factoring, and we are going to be given the trinomial, which is called a perfect square trinomial. It's called a perfect square trinomial when the first term is a perfect square, the last term is a perfect square, and there's our 2ab in the middle, which is the square root of each of these multiplied by 2. So just going backwards from what we just looked at, this one becomes a plus b quantity squared. This one will be a minus b quantity squared. Okay, have a perfect square and a perfect square. So take the square root of x squared, take the square root of 16, take the sine of your middle term, and then you square it. And if you multiply these two, x times 4 times 2, you get that middle term. Alright, take the square root of 4n squared, 2n. Take the square root of 9. Oops, it's not 9. The square root of 9 is 3. Take the sine of your middle term, and 2n times 3 is 6n times 2 is 12n, so we know that we've done that correctly. And the last one we have is factoring a difference of two squares. Okay, the key here is that it's got to be a difference. Okay, that means subtraction. Okay, a squared minus b squared factors to a plus b times a minus b. So I got a perfect square, another perfect square with subtraction in the middle. Take the square root of x minus the square root of 64, and then switch the sign for the other factor. Remember, it's multiplication, so the order that you write the factors does not matter. Okay, square root of 25x squared, 5x, minus square root of 36 is 6. And again, write it again, just change the sign. So let's go do some more, trying to remember. So we have to recognize the difference. Let's go label this real quickly. Okay, when we talk about this, this is a perfect square trinomial. So we're going to label it perfect square trinomial when we go through. This is the difference of two squares. So I wrote this one like this, the difference of two squares. Okay, so look at what we have. It's a trinomial, so these are both perfect square trinomials. Hopefully, we'll find out. And when we factor, okay, it's something squared. You take the square root of that term, the square root of your last term, and the sine of your middle term. And there you have it. And you can check it. X times 3 is 3x times 2 is 6x. Okay? First term, last term, and the sign of the middle term. So we are taking something from each term in our perfect square trinomial to be able to factor it. Okay? You're building a square patio. The area of the patio is represented by this trinomial. Okay? The key word here is square. So that means this represents a square. What would be the length of one side? So we're going to do what we've been doing. We have a PST on our hands, which is a perfect square trinomial. Take the square root of the first term. Take the square root of the last term. Take the sine of my middle term. And square the quantity. And there we have our perfect square trinomial. Okay? I have two terms. So since I have two terms, it can't be a perfect square trinomial. So we hope that it is the difference of two perfect squares. Okay? Two squares. So v squared minus 100. Square root of v squared is v. Square root of 100 is 10. And this time we have to write two factors. Will look exactly the same, except for one is positive and one is negative. S squared minus 16, square root of s, square root of 16. One is negative, one is positive. Okay, and here we have one with a coefficient on our first term, but it is still a perfect square. 25d squared. Square root of 25 is 5d. Square root of 64 is 8. One will be positive and one will be negative. And the last one we have, they put them both together, so we got to figure out what we have. Two terms, okay? Two terms are going to factor. If there's two terms, I'm going to have two factors, okay? Three terms is the one factor squared. So two terms, something a little different about these, okay? I didn't look to see if I had a perfect square, so hopefully y'all can notice that 12 is not a perfect square, so what that means is we got to look for a GCF first, okay? So my GCF in each of these cases, what number goes into, I think 12 goes into both of these, so that gives me 12 t squared minus 4, and there are my two terms which factor into two factors, because that's a perfect square and that's a perfect square, and I have subtraction. So t squared of 4 is 2, gives me t plus 2, t minus 2. Over here, again, 12 is not a perfect square. 3 is, so I'm going to factor out my 3. That leaves me with 4x squared plus 4x plus 1. Now I have a perfect square and a perfect square, so let's see if that doesn't work as a perfect square trinomial. Square root of 4x squared, 2x. Square root of 1 is 1. Get my sign from the middle term. 2x times 1 is 2x times 2 is 4x, which is my middle term. Okay? So, you can see it's really important to know our perfect squares. So the last thing I want to do is actually write them so that you can remember. 1 squared. Let's write a little chart here. And we have x, and then we'll have x squared. So if I have 1, 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. Just a little bit longer. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. We'll stop there. 12 squared is 144. And I'm going to jump to 15 squared is 225. So those are your squares that you want to recognize to help you be able to factor your perfect square trinomials.